You know, there's a hidden danger that could be lurking in even the most beautiful orchid collection. It's this invisible threat, something that can quietly and completely devastate years and years of careful work.
So just think about that stunning orchid you have. Maybe it's on your windowsill or in your greenhouse. You know the one I'm talking about. Is it possible it's hiding a secret, one that could put your entire collection at risk?
Maybe you've even seen some of the signs and just brushed them off. You know, a few strange spots you thought were maybe sunburn, or a flower with some blotchy, broken color. Or maybe you've got a plant that's just failing and you can't figure out why. Well, these are clues, and trust me, they are not random.
Yeah, the culprit behind all this might just be an incurable virus. So to really understand this invisible enemy, we need to think like detectives. It's time to investigate the evidence.
Okay, first up, a sickness in the greenhouse. Now, to really get the scale of this problem, you have to realize this isn't just some minor pest issue. We're talking about a major threat, not just for hobbyists, but for the entire multi-billion-dollar global floriculture industry. And why? Because these things are systemic, they're incurable, and they spread silently.
So, in our investigation, who are the main offenders? Well, while there are over 30 viruses that can hit orchids, just 2 of them are responsible for the vast majority of cases. So, let's meet our prime suspects. On one side, we've got Cymbidium mosaic virus, or CymMV for short. Picture it as this flexible, kind of thread-like particle. And on the other side, Odontoglossum ringspot virus, ORSV, which is a stiff, rod-shaped particle. Now, that difference in shape might seem like a tiny detail, but it's absolutely crucial. It's what dictates how they behave and what makes them so incredibly tough to get rid of. Think of this as the official rap sheet for our 2 culprits. CMMV is a Potex virus, a group that's known for causing those mosaic patterns and, in orchids, blossom necrosis. And yeah, it's very stable in plant sap. But then you've got ORSV. It's a tobovirus, a family of notoriously tough plant viruses. It causes that classic color break symptom, and get this, it is extremely stable. It can survive for years on dry surfaces, which makes it an absolute nightmare to eradicate. All right, so every good detective knows you have to examine the evidence at the crime scene. And for us, that means learning to read the telltale signs, those unique symptoms that these viruses leave behind on an orchid's leaves and its flowers.
What's wild is that the virus's signature really changes depending on the victim. You might see this really distinct diamond pattern on a Cymbidium, or a sunken purplish lead necrosis on a Cattleya. On a Phalaenopsis, it might start as yellow streaks that turn black. The thing to remember here is the sheer variation, especially with a plant like a Vanda, where the signs can be so subtle you might miss them completely.
Now let's talk about maybe the most infamous symptom of all, flower color break. This is the absolute calling card of ORSV. See, the virus messes with the plant's ability to produce its color pigments, the anthocyanins, evenly. And what you get are these beautiful but really tragic streaks and blotches. The flower's color is quite literally broken. CMV has an even more sneaky trick up its sleeve, something called blossom necrotic streak. A flower can open up looking absolutely perfect, totally healthy and ready for market, but then 1 to 3 weeks later, these brown necrotic spots and streaks start showing up, completely destroying its value. It's this delayed threat that can ruin an entire shipment of cut flower. Okay, so before we can convict our suspects, a good detective has to rule out the imposters. And there are a lot of them. So many other common greenhouse problems can produce symptoms that look shockingly similar to a virus.
So how in the world is a grower supposed to tell the difference? Is that yellowing leaf a sign of a virus, a fungal attack, or just a simple nutrient deficiency? This right here is the core challenge of trying to diagnose by eye.
So how do we start to build the case? Well, the trick is to recognize that nutritional issues usually follow predictable patterns. For instance, nitrogen is a mobile nutrient, right? So the plant pulls it from its older leaves first, which makes them yellow uniformly. Calcium, on the other hand, is immobile, so a deficiency shows up as black tips on new growth. Viral symptoms, though, they don't follow these rules. They tend to be random, patchy, and streaky.
And it's the exact same story with fungal and bacterial spots. They have their own calling cards too. Bacterial brown spot, for example, which is really common in Phalaenopsis, often shows up with this distinct yellow halo around the spot, or it can even ooze a little liquid. These are features you will not see with a viral infection.
But you know, at the end of the day, visual clues and ruling out imposters, that can only get us so far. To be 100% certain,
Our investigation needs forensic evidence. We need to find the smoking gun, and that means diagnostic testing.
And testing is absolutely critical. Why? Because co-infections are incredibly common. I mean, in some nursery surveys, over 35% of the orchids they tested were infected with both CMBOs and ORSV. And when those two get together, things get a whole lot worse.
This leads to this really dangerous phenomenon called viral synergism. The easiest way to think about it is like this. 1 + 1 = 5. When both viruses are in the plant, the symptoms show up faster, they're way more severe, and the plant declines much, much more rapidly than it ever would with just one of the viruses alone.
Now for some good news. You don't need a forensics lab to get a definitive answer. There are at-home tests, like these ImmunoStrips, and they basically work just like a home pregnancy test. It's so simple. You just crush a little piece of leaf tissue in the buffer bag they give you, dip the strip in, and wait. You'll see one line pop up. That's the control line, just confirming the test is working. But if a second line appears, that's your positive result. So, let's say our investigation has confirmed a virus. The case is solved. What now? Well, this is the final and honestly the most important step, protecting the rest of your collection. This is all about prevention.
Let's start with your tools, because they are the #1 way these viruses are spread. And listen, a quick dip in alcohol or passing them through a flame, that is not enough for these tough pathogens. You need a rigorous two-step method. First, you have to physically clean the tool with a detergent to get all the sap and organic gunk off. Only then can you actually disinfect it by soaking it in a proper viricide like 10% bleach or trace sodium phosphate.
Honestly, building smart habits is your absolute best defense, and they all circle back to one single principle: preventing mechanical spread. The virus travels on our hands and our tools, so anything that touches one plant should not touch the next one without being sterilized or just thrown away. That means using disposable blades, changing your gloves, and sterilizing your pots and work surfaces between every single plant.
Okay, now for the really hard part. The final verdict for a plant that tests positive is destruction. I know it's difficult, but just trying to isolate it is way too risky. There is no cure, but, and this is a crucial point, there is a path forward. These viruses are not transmitted through seeds, so seed propagation is a totally reliable way to create clean, virus-free plants from an infected parent.
And that really brings us to our final thought for today. Given how widespread these incurable viruses are and how much they threaten the entire orchid industry, will our ability to enjoy these amazing plants in the future ultimately depend not on sanitation, but on science, on genetically engineering plants that have built-in resistance? It's a pretty fascinating question to think about. Thank you for joining me.